Here is the bubble sort algorithm explained in Python. So here's our function. It's going to take in the array, and we're going to start off initializing. Metaswap is true and n is the length of the array. We're going to execute this while loop. We immediately set metaswap to false. If we end up making any swaps, that means we are not yet done sorting, and so we need to go over the loop again. The core essence of the algorithm is right here for I in range of n-1. So you're going to start at 0, and you're going to go through all of the indices until the very second last one we're going. To always compare array I to array I plus 1. If the left is bigger than the right, then you're going to just swap them. This code here just swaps them. We get a temporary at the left one. We set the left one equal to what's at the right. We set the right one equal to what's at the left, or that temporary. And then we signal that we've made a swap so that we do this thing again, so that we keep on doing this sorting algorithm. So conceptually, here's the process of taking the input to its final output. We look at 5 o'clock and 3 o'clock, and we're supposed to swap them. So we swap them. And then we've signaled, hey, we are going to go through the array again. So we're not done sorting. Do we swap 5 and 1? Yes, we do. 1 and then 5. Do we swap 5 and 2? Yes, we do. 2 and then 5. It's gone through, and we know that we made at least one swap. So it goes through again. Do we swap 3 and 1? Yes, we do. Do we swap 3 and 2? Yes, we do. Do we swap 3 and 5? No, we don't. But we still made a swap. Swap. So we're going to go through again. Do we swap 1 and 2? No. Do we swap 2 and 3? No. Do we swap 3 and 5? No. Our algorithm is complete, and we fully return our array. We would say that this algorithm has a big O of n squared runtime, which is really slow because we basically have a for loop through the array, and in that we have another for loop in the array, so n squared. But the space luckily is O of 1 because we are just swapping in the array itself, which takes up no additional space.